It is going to be one of the most spectacular shows in history. And it could happen at any moment. I mean, this is the thing. I often stand outside in my yard in the wintertime. I look up at Orion and I see Betelgeuse. And I'm like, explode!
Renowned astrophysicist Neil deGrasse Tyson just made a bold prediction that the dramatic dimming of supergiant star Betelgeuse could become an epic supernova explosion, poised to take the night sky all over the world across every continent in the coming months. But what does it mean when a gigantic star like Betelgeuse exhausts and goes supernova after 10 million bright years? What might the fireworks finale, 642 years in the making, reveal about cosmic interconnections? Join us on a journey exploring Betelgeuse's impending storybook ending that will take the night sky all over the world. Number 1. Betelgeuse explosion will take the night sky all over the world. Stargazing, a captivating hobby, requires nothing more than a clear night sky and your unaided eyes. On such nights, the vast expanse of the sky above dazzled with thousands of stars, evoking a sense of awe and significance. Among these celestial dots, Betelgeuse, a red giant, commands attention, especially when it is part of the renowned Orion constellation in winter. Positioned as Orion's right shoulder, Betelgeuse radiates a vibrant red hue despite its recent enigmatic dimming. Scientist Neil deGrasse Tyson sheds light on Betelgeuse's quirky behavior and its allure for astronomers. This huge star is unsteady, flickering every now and then. Despite its distance, thousands of light years away, Betelgeuse dwarfs our yellow sun in size. The mind-boggling revelation is that astrophysicists speculate that Betelgeuse may be on the verge of a spectacular explosion. As giant stars like Betelgeuse approach the end of their life cycle, they erupt into a supernova, a cosmic spectacle of epic proportions.
If we take the lines away, the most interesting star, I think, the star that could be shocking in our sky is this one, Betelgeuse or Betelgeuse. It's a red giant star. If you put it where the sun is, it would extend out to the orbit of Jupiter. It's enormous. It's very unstable. It's about to explode.
Despite recent dimming, Tyson suggests that Betelgeuse's grand display might still be in the offing in the coming weeks, months, or years. Given its distance, a staggering 25,000 light-years, we are witnessing an event that occurred 642 years ago, a celestial show unfolding before our eyes. When Betelgeuse eventually explodes, it is expected to outshine the moon in our sky. The supernova's brilliance will cast striking shadows during the day, promising a breathtaking celestial event for a generation of stargazers. Tyson reassures that Earth faces no danger. The explosion's contents will disperse harmlessly into space. Anticipation builds as we await Betelgeuse's extraordinary cosmic performance. Telescopes trained on Orion might capture the initial shockwave and gases before the naked eye perceives the celestial drama. Tyson envisions families worldwide gathered under the night sky, witnessing the brilliance of Betelgeuse. The prospect of creating enduring memories under the stars, especially for children and parents, adds to the extraordinary privilege of observing a red giant supernova. Number 2. Betelgeuse's illuminating tale across the cosmos. Betelgeuse, the stellar sensation, has carved its place in celestial lore, captivating us in song, thanks to the Betelgeuse movie, and fascinating astronomers alike. Let's delve into Betelgeuse's narrative and explore the reasons behind the keen scientific scrutiny of its brightenings, dimmings, and pulsations. This red supergiant, positioned nearly 650 light-years away, has been a fixture on Orion's shoulder since long before telescopes turned in its direction. Ancient civilizations like the Aztecs and the Chinese have told mythical stories about the variable nature of this star. When Betelgeuse mysteriously flickered and revived over months or years, they interpreted celestial omens and messages. While mystical interpretations have waned, our scientific understanding of this neighboring star has expanded significantly. Up close, our stable yellow sun would vanish within the vastness of Betelgeuse. Imagine fitting over 1 million planets our size inside. Despite its seeming serenity, Betelgeuse experiences violent convulsions due to scorching 600-degree surface temperatures and colossal energy output. The intriguing part? Betelgeuse burns so intensely that astronomers estimate it has likely depleted its hydrogen fuel. which feeds the fire, in a mere 10 million years. Compare this to our Sun, projected to shine for a total of 10 billion years. Betelgeuse, lacking the fuel for sustained nuclear fusion, hurtles rapidly towards its catastrophic fate. The inevitable disaster? A supernova explosion, as Neil deGrasse Tyson discusses. When Betelgeuse exhausts its stellar fuel, the gravitational collapse begins. Betelgeuse essentially implodes under its weight, triggering a colossal explosion that sends shockwaves racing outward at 186,000 miles per second, visible to us across 600-plus light-years. So, stargazers, keep those telescopes fixed on Orion's shoulder. While Betelgeuse may seem strong and steady tonight, a cosmic cliffhanger looms. Whether the supernova spectacle unfolds next year or in another century, expect a narrative full of twists, turns, and surprises. When the light from Betelgeuse's swan song reaches us, Neil deGrasse Tyson anticipates gaining crucial insights into red giant stars. Unlike observing extinction events from the past, we have a front-row seat for this stellar endpoint, determining the star's ultimate fate. In the aftermath, nebula gases will enrich galaxies with heavy elements, forging new worlds. It's the universal circle of life and destruction, written across the cosmos. Number 3. Betelgeuse's dimming and the universe's surprises. Betelgeuse, that cosmic riddle, keeps astronomers on their toes. Just when they thought they had the star's routines figured out, it threw everyone for a loop by plummeting nearly 65% in brightness to an unexpectedly dim state. What's the cosmic drama behind this stellar performance? Neil deGrasse Tyson reminds us that what we perceive as a continuous dot in the night sky is actually a time machine, a panorama unfolding events from 600 years ago. We are observing Betelgeuse's past developments without real-time knowledge of its present status today. So, the celestial spectacle we're reacting to now predates the age of New World exploration and Shakespearean plays. The collective jaw drop across global observatories is understandable. Seasoned skygazers, accustomed to 3 decades of modern observations, had never witnessed Betelgeuse looking so consistently faint until the 2019 Great Dimming episode. While brief dips had occurred before, none matched the duration and gloominess of this extended dimming, akin to watching high beams fade and persist as nightlights. Curious scientists turned their electronic eyes to the skies through telescopes, searching for clues. Theories abound, from speculations of an imminent stellar explosion to more cautious considerations of space dust as the culprit. Delving into records dating back to 1920, astronomers found instances of Betelgeuse experiencing short-term light decreases, but none reaching below the 50% dimness level. Late 2019's fading, dwindling to just 35 to 40% of normal luminosity, proved unprecedented. What had cast such a dramatic shadow over Betelgeuse? Global stargazing partners shared photo evidence that eventually supported the guilty dust explanation. In 2021, Japanese scientists presented telescope captures suggesting ejections of cooled plasma from Betelgeuse, forming curtains of particles directed toward us. Surprisingly, the star hadn't experienced an internal power dip, but rather orchestrated its own dimming with a cosmic brushstroke. Mystery solved? Not so fast, junior detectives. Like a mischievous suspect caught red-handed, Betelgeuse had another surprise up its sleeve. Later findings traced the origins of the dimming to silicon monoxide, revealing that Betelgeuse was the source of its own dimming screen. The plot thickens. While the primary switch for the Great Dimming appears to be space dust rather than an impending supernova, many stellar researchers remain hesitant to rule out an explosive finale. Massive stars, nearing the end of their fusion fuel, may experience fiery outbursts aiding collapse, akin to a dying campfire sparking upwards just before extinguishing. With cosmic distances limiting our real-time data, surprises still await in the cosmic theater. Number 4. What does the dimming of a star tell about supernovae? What's with this dimmer switch behavior Betelgeuse has been demonstrating lately? Well, Neil deGrasse Tyson says we need to understand that stars normally fluctuate in brightness based on activity cycles, a stellar mood ring showing their feelings, you might say. But when extreme dips occur, like Betelgeuse dropping 65% less luminously, seeming like a porch light struggling on weak batteries, alarms sound. signaling possible problems afoot. Science asks, could the star be building towards a drastic finale called a supernova? While not guaranteeing an explosion, such major darkening episodes can relate to a grand star's unstable final act, according to astronomers. They've concluded that really huge stars around 15 times our Sun, or more, gulp fuel ultra-fast in nuclear furnaces, meaning shorter lifespans. Up to 1 million times wider than the Sun, with way more mass containing such immense gravity, runaway processes spark, leading to inevitable core collapse sometime soon. Well, actually 642 years ago. So, what does the dimming signify then, regarding when Betelgeuse detonates its explosive blast across hundreds of light years? Well, the curtain effect likely means big clues to coming attractions. Runaway fusion heading for meltdown suggests turbulence ahead. Imagine the star's outward pressure against crushing inward gravity, which is weakening steadily over time. This leaks energies that spark extensive mass ejections. Fuel intermittently surges and sags, setting up the instability stage. It's like seeing an idling old car shudder and stall at that stoplight before finally refusing to restart. The dramatic brightening always accompanying supernovae typically occurs in the days, weeks, or months directly preceding the big shattering kaboom due to collapsing core processes. So, in summary, extreme drops in luminosity can signal instability hitting critical levels where gravity gains full traction, leading to the light going out permanently. It may not be the supernova event quite yet, but rather the prelude intermission building suspense before Act 3's shocking climax. In Betelgeuse's case, medieval astronomers reporting weird fainting spells hundreds of years ago were likely witnessing previous pre-supernova unrest, shaking its stability. Today's unrivaled great dimming dip and its steady pulsation brightness fluctuations strongly indicate that rot deep inside Destiny's fuse is now burning fast. Will our generation get to have a glimpse of Betelgeuse's violent farewell blast across lonely light years, linking the past and present? Are future children blessed to witness the prophesied supernova of 2022 or 2023 due to arrive like a celestial time capsule, carrying Orion's message from long ago? The glow surrounding Orion's shoulder tonight appears reassuring and calm, just as it has for ages. But telescopes aimed at Betelgeuse's way may spot fury increasing within the unstable giant any year now, as the ending nears 642 years later. In space, looks prove truly deceiving, as that eventual brilliant flash will prove. Number 5. Betelgeuse's final act and the birth of legends. Betelgeuse is putting the super in supergiant, as shown by its monstrous size and mass, which are almost unthinkably huge compared to many stars. Our stable sun seems petite, weighing just 1 in 1,000th the amount of incredible Betelgeuse. You could imagine stuffing over 1 million of our solar systems into just one swirling corner with this red beast, despite the humongous size suggesting a long-lasting life. In truth, Betelgeuse rapidly spent itself by burning too brightly over only 10 million years, a blink of cosmic time suggesting an early demise. According to Degrasse Tyson, 2 possible exit routes exist when flawed superstars like Betelgeuse exhaust supply lines of hydrogen and other fused elements that are keeping the inferno raging. Will it blow completely apart or shrivel away into the void? The most speculated ending is an iron core collapse that will trigger a dazzling supernova explosion. A fuel logistics breakdown means no more balancing the outward thermal pressure, so the star caves in on itself catastrophically. Then, in spasms, the rebound detonates the star's outer layers in a blinding flash, racing along at 186,000 miles per second. What about a slower-acting alternative demise? If the mass is shed adequately from the aging Betelgeuse beforehand, loss of gravity traction will hinder its full collapse. The lingering white dwarf star becomes an ashen cinder, gradually cooling to eternal darkness. Like a campfire going out with sand, the burning logs collapse and turn into bits of fading embers. Either the closing act suits Professor Tyson just fine since recording a star's life cycle via supernova, or a collapse offers a scientific bonanza of gathered insights. By luck, we exist at the perfect viewing distance to study exquisite details about the instability factors, tipping the balance towards Betelgeuse, blowing up or shrinking to retirement. His dream of defying astronomical odds, witness Betelgeuse's extinction finale, now past, and subsequent gravity wave arrival, future, proving Einstein correct about ripples in space from great stellar upheavals. Talk about advanced notice of the celebration across 642 light-years. Whether climactic blast or fading denouement, both represent Mother Nature's stellar recycling program, revitalizing the Milky Way galaxy with dispersed heavy elements and seeding future solar systems like our own. Destruction becomes a gift, paving the way for a new life among the stars. The prospect of the current supernova possibility invites us to reflect on ancient sky-gazers, who too must have pointed upwards, exclaiming, "What bright red star is that?" The famed supernovae of 1054 AD and 1572 left an indelible mark on history and art, their echoes captured in records and paintings where astronomers mixed colors just to recreate the ephemeral brilliance that had already faded. So, whether you find yourself in the daylight awaiting nightfall or already scanning the skies at dusk, take a moment to contemplate the mysterious Betelgeuse. Position your cameras, unless of course 642 years ago, it already spectacularly flashed, a spectacle unseen until the prophesied light arrives in the coming months or years, transforming global star party celebrations. Whenever and wherever it occurs, don't miss astronomy's messenger from the past. Number 6. Betelgeuse's message to future civilizations. The light that left Betelgeuse 642 years ago to reach Earth now carries an intriguing message, not just about the life cycle of stars, but about the evolution of intelligent life as well. Famous scientist Neil deGrasse Tyson speculates that if Betelgeuse's eventual supernova outburst shines brightly enough, future spacefaring civilizations may detect evidence of the explosion thousands of years from now, like a cosmic lighthouse beaming across the galaxy. Perhaps they will correctly deduce that way, back in the 21st century, Earth scientists predicted the impending fireworks show even while lacking interstellar travel capabilities or the means to record it directly. What might these advanced societies piece together about early human understanding of astronomy from the relics and records we leave behind? With modern satellite debris in orbit, obsolete observatories on the ground, and our warning alerts to look skyward, the intriguing thought highlights how a single stellar event can create unexpected bonds, spanning not just centuries, but entire civilizations separated by gulfs of time and technology. Imagine brainy beings elsewhere pondering images of Betelgeuse's cascading shockwave, yet unable to comprehend the society capturing those first grainy portraits. The aliens may ask themselves in bafflement that these Earthlings knew the cataclysm was coming, yet continued about their brief affairs. Why did they care what happened 600 years later? Of course, Tyson suspects no evidence of Earth may remain for ET detectives that far in the future, let alone deducing the astronomical capabilities of one extinct race. More likely, bold, long-range explorers would need to put together clues about the impending Betelgeuse supernova from its original 642 light-years distance, compare findings on expansion rate, and trace everything backward with computers to pinpoint roughly which century the big blast erupted based on their advanced knowledge of astrophysics. Indeed, the thought of emissaries visiting the charred remains of Sol 3 one day, casting their inquisitive eyes toward Orion, and discovering that observers here long ago foresaw the very same cosmic event, now memorialized as historic in their own culture, is fascinating. Alternatively, they might misinterpret the remnants of Mount Wilson and Hubble relics, concluding that we worshipped Orion as an actual deity. Tyson chuckles at the possibilities, finding joy in speculating on how a solitary star can create bonding moments across the void, connecting vastly disparate beings. Number 7. Betelgeuse and Hollywood's imagination. While astronomers patiently monitor Betelgeuse's variable brightness cycles that may indicate eventual cataclysm, Neil deGrasse Tyson acknowledges pop culture's parallel fascination with supernovae and global light shows depicted on film. Of course, these are driven more by computer-generated fantasy than the laws of cosmic plasma physics. Recent sci-fi thrillers exaggerate the hazard potential, as if nearby stars detonating could actually threaten our survival. Tyson laughs that unlike the melodramatic movie plots obsessed with radiation threats, and impending planet-wide doomsday destruction raining down from the heavens, the only real-world danger from a Betelgeuse supernova is developing a stiff neck from excitedly craning upwards for months on end. Even dire warnings about ozone depletion and elevated ultraviolet exposure will likely prove minor and short-lived in the aftermath of such a distant stellar outburst. Still, Hollywood blockbusters do perform a meaningful public service, Tyson feels, by intriguing mainstream crowds with notions of real astronomical events unfolding beyond our atmosphere in vivid, dramatic fashion. Even as disaster flicks twist science toward terrifically bad astronomy, they do serve to spur initial wonder and curiosity about perhaps investigating the truth underlying their clickbait headlines. While the silver screen often deals in fiction, it also provides a gateway for showcasing the genuine astronomical reality of luminous stellar endings. When accurately revealed through articles and documentaries, these cosmic events become fantastically appealing, drawing newly enchanted skywatchers to crane upwards and conduct their own telescopic research. In the role of bridging entertainment with education, Tyson approves of popcorn supernova movies, acknowledging that in the coming years, they might just help fill eager midnight observatories. Number 8. Understanding the Sun's Future through Betelgeuse. It's sobering yet fascinating for Tyson that only 10 million years ago, mighty Betelgeuse burned as brightly and enduringly as our familiar sun. However, its reckless rate of hydrogen consumption demanded exceedingly rapid fuel consumption compared to the sensible Sol. Now doomed, monitoring advanced telescope observations detailing Betelgeuse's dire instability and likely imminent supernova finale offers our solar astrophysicists crucial insights about our own star's destiny 6 billion years later. Like studying a genetically engineered lab mouse designed to mimic accelerated human-like aging patterns at a vastly sped-up rate for medical detectives, Betelgeuse's unprecedented quick-burn evolution helps us truly appreciate just how precious our sun's stable longevity remains, courtesy of that masterfully balanced hydrogen fusion act burning away inside. By examining Betelgeuse as a cautionary, flawed celebrity look-alike, succumbing young and fast to stellar entropy, scientists better safeguard Earth's smooth ride around a sensibly moderate nuclear burning torch for eons to come. How life-saving it is to peek generations ahead by checking in on Orion's ticking time bomb before our own front door becomes similarly explosive. Through detailed spectrographic analysis, plus theoretical models reconstructing the dynastic processes giving birth to eventual Wolf-Rayet stars destined to detonate, astrophysicists better plot stellar parenting manual guardrails to steer the future Sol twins down a more promising evolutionary path. Like plotting the hereditary medical markers that keep descendants thriving, our coming sun-like siblings need not follow in Betelgeuse's footsteps just because they burn the same. By learning exactly what fusion ingredients, mass proportions, and containment approaches trigger instabilities down the road, future star nurseries can tweak their gas recipes and ensure a longer glow. And should ash accumulations suggest instability gathering ahead, midlife stellar interventions might bleed off and start accumulating heavy metals or regulate densities, preventing premature explosion. Number 9. Betelgeuse and the Secrets of Stellar Alchemy. In Neil deGrasse Tyson's contemplation of Betelgeuse's impending fate, he envisions a monumental event that will not only mark the red giant's demise, but also illuminate our limited understanding of the intricately complex stellar alchemy occurring within the secret furnace hearts of stars over almost unimaginable eons. The aspirations of medieval earthly alchemists, who sought to unlock the secrets of transmuting elements into gold, pale in comparison to the synthetic transmutation processes transpiring within stars. The cataclysmic demise of stars forged the very atoms of carbon, silica, and iron, crafting the precious elements that have adorned pharaohs and kings throughout history. Exploding stars play a vital role in contributing to the silver and gold lining of Earth's crust and mineral resources. Betelgeuse, with its aging and wildly unstable cores, becomes a cosmic laboratory where advanced particle processes and secret quantum mechanics transform basic hydrogen into more complex elements, ultimately reaching iron in row 26, of the periodic table. This alchemical reaction occurs under unimaginable pressures and extreme temperatures, found only within the bellies of stars, a process that remains elusive to our understanding. The detonation of Betelgeuse becomes a source of excitement for scientists like Tyson, presenting a unique opportunity to unravel the secrets of star alchemy. The resulting spray pattern and velocities of ejected stellar material hold encoded clues about cosmic element creation recipes. Spectrographic analysis may unveil the step-by-step chemical evolution, mapping the journey from the Big Bang afterglow to the present workshops in Orion. While Betelgeuse's explosive grand finale might not replicate the dreams of ancient alchemists by turning lead into gold, studying its detonation becomes an uplifting exploration into how simple hydrogen and particles from the dawn of creation undergo a celestial makeover through star life phases. This transformative process shapes the essential elements that become the cosmic building blocks of planets, the vital molecules for life chemistry, and perhaps even the magical sparks that lead to life itself in distant worlds. Betelgeuse, in its spectacular swan song, becomes a cosmic storyteller, narrating the exuberant saga of stellar alchemy that resonates joyfully throughout the cosmos. Number 10. Betelgeuse and red giant genetics. Contrary to the commonly depicted singular catastrophic explosive event, Neil deGrasse Tyson suggests that Betelgeuse's prolonged demise leading up to its climactic supernova finale likely involves numerous serial, smaller periodic dimmings, spanning decades of plasma instability phases. This fits and starts pattern of convection churning and partial gravitational collapse events seems to foreshadow the unavoidable kaboom ending to come. In this manner, Betelgeuse structurally mirrors the serial rebirth life cycles of organisms like crabs, lobsters, and spiders on Earth, shedding their calcified outer shells when outgrowing current limitations. Betelgeuse's gradual molting, decade by decade, across recent centuries, before its final fiery photospheric layer collapses inward, offers extended observation periods for stellar astrogeneticists. This prolonged cyclical transition from stable adulthood to elderly red giant instability stages provides rare opportunities to decode key mutation markers and evolutionary DNA blueprints, governing longevity, demise thresholds, and explosive evolutionary pathways. Astronomers using Betelgeuse as the ultimate test subject are looking to uncover the cosmic gene analog sequencing codes triggering processes generating helium ash stellar cores and dense carbon fusion shells, observing the unfolding genetics governing particle, plasma, and dust production from increasingly unstable fusion reactions in Betelgeuse's spectra promises invaluable insights. This quest parallels the breakthrough Human Genome Project, aiming to discover, map, and comprehend fundamental master genes steering biological processes. Recording every phase shift and internal remodeling throughout Betelgeuse's total serial life cycle, march towards supernova demise will uncover seminal stellar DNA analog blueprints and critical mutation sequences dictating red giant star lifetimes. The achievement will empower astronomers to shape genesis factors in future solar systems by intentionally breeding Sol twin candidate stars with increased desirable longevity traits. The capacity to seed future clusters and galaxies with superior successor generations of stars, intentionally birthed via stellar engineering, will be informed by insights gained from Betelgeuse's explosive process. Orion's fiery red giant will become astronomy's detailed library, documenting deleterious instability and entropy factors to be avoided in cosmic stellar engineering. This marks a transition towards programmed intelligent design goals, offering a profound understanding of the cosmos and the deliberate crafting of stellar legacies. Number 11. Betelgeuse has also been sparking cultural imagination. While Neil deGrasse Tyson and researchers around the world track Betelgeuse's diminishing brightness as a crucial scientific endeavor, the unfolding celestial saga has also sparked fervent cultural fascination beyond academia. As one astronomy journalist, Bob King, observed, Betelgeuse has captured the public imagination, unlike few other stars in recent decades. Its monster size, bright red hue, and association with a beloved movie character have already made it an object of intrigue. Now add the allure of an impending catastrophe, and it's no wonder everyone from scientists to tweeters to artists is so enthralled. This dramatic star has ignited creative speculation and imagination among the general public, on a scale unmatched since Halley's Comet. Betelgeuse has long been interwoven in literature and myth as the easily visible supergiant star, marking the prominent hunter constellation Orion. Yet now, with its recent conspicuous dimming, complex theories about its unstable fate, and potential for an extraordinary supernova spectacle, Betelgeuse is propelling a 21st century resurgence of inspired pop culture references across mediums. DIY astronomers have flocked in droves to catch a glimpse of Orion's fading giant through personal telescopes. A Reddit subgroup with over 50,000 members actively tracks every fluctuation in brightness and astronomical observation relating to the star's demise. Renowned fictional universe franchises have featured Betelgeuse prominently, with TV shows like The Simpsons cheekily suggesting it go nova. Speculative doomsday and apocalypse plots in films jokingly threaten that Betelgeuse may go boom any day now. Fan communities sharing astrophotography and simulated portraits of a fiery Betelgeuse supernova have spread widely on social media. Amateur night sky painters have depicted Orion consumed by scintillating cosmic shockwaves. This cultural hype looks toward the heavens with excitement rather than fear, to witness an extremely rare glimpse into mortality, rebirth, and eternity written across the stars. Tyson welcomes mass public intrigue, drawing attention to monumental astronomy feats beyond celebrity gossip. He hopes that when at last the fated photons from a Betelgeuse explosion arrive in Earth's skies, people gaze up together rather than through phones, pondering both star and human life cycles' impermanence against the night's infinite expanse that has awed our ancestors under Orion for millennia. The James Webb Space Telescope is lighting up the world like the Betelgeuse supernova would, with its launch of brand new JWST special edition phone cases. Get yours by clicking the link on the screen or following the link in the description. Thanks for watching. Like this video and subscribe to our channel for more updates. And while you're still here, click the video on your screen for more mind-blowing videos.